configure the interactive tuning, we start by following the same procedure that is used to create EQ curves from the workspace. We go under Tune, then EQ, and then we double-click on the group of speakers that we want to measure first. In this case, we will start with the top array, as it contains more high-frequency contents. With a double-click, we're taken to the EQ window, and here at the bottom left corner, we will find this little icon that resembles the meters of a mixer. Click on it, and we will open the interactive tuning pane. Now we need to enable the connection between ArmoníaPlus and Smaart, and to do that, we move from ArmoníaPlus to Smaart, and then when in Smaart, in the main window, we go under Options, and then select API. This will take us directly to the API tab in the Options window, from where we can enable the connection with Smaart via our network. We can keep port 26,000, and we can see that Smaart automatically generates an IP address that can be used for communication with ArmoníaPlus. We then click Apply to store our settings, and next, we move back to ArmoníaPlus, and from the quick bar, we select the gear icon to open the Options window. We then go under the Interactive Tuning tab, and we select Smaart from the Extensions drop-down list. We can also select the path to the folder where we want to save our EQ curves. And finally, we select Smaart V8 as the type of analyzer that we want to connect ArmoníaPlus to. Then we click on the Refresh button to reload the IP addresses available, select our IP address, and click Apply. A signal generator from Smaart instantly appears in the interactive tuning pane. We can hit play to start running the generator, and apart from this generator, which we will use to run our measurements, we can also access the measurement microphone connected to Smaart by clicking Enable under Play Status. So let's do some basic setup before we start our measurements. Let's click on Magnitude and Phase to view their live responses in the EQ window and maintain a long average period of 3 seconds to minimize distortion and provide a more stable measurement. We also need to compensate for the delay time in our transfer function measurement. To do that, we can use the Delay Finder tool from Smaart, accessible here in ArmoníaPlus. We will use it to measure the delay and then insert it in our frequency response measurement. Once our setup is finished, we can click on Capture to record our measurement. Let's just stop the generator for a second and then select our measurement and give it the name Top. And since we're currently working with the top array group, we can activate the EQ iteration for the measurement over this group either by ticking the checkbox next to the gain value or by clicking Enable under EQ interaction in the Properties pane. Let's mute our top group for a moment and let's go to the EQ window of our subs group. Now let's unmute our subs group and turn the generator on again. We can maintain the same delay compensation, and because we're dealing with the low frequencies here, we will just wait for a few seconds for our measurement curve to stabilize. There we go. We then click Capture to record our measurement, stop the generator, hide the live magnitude and phase, select our latest measurement, rename it Sub, and finally, enable the EQ interaction for our measurement with the subgroup. Let's now click to view the magnitude response curves of both top and sub measurements. And just to organize our window a bit better, let's use the crop tool to edit, only graphically, the bandwidth of our magnitude curves to display only the information we're interested in. So now we can sum these two curves, and to do that we click More, and then select Math. In the Math window, we then select the Sum function. We then need to select both our curves, which will be summed to create a third one, and make sure that the Generate Live curve is selected, so that this new curve is ready to interact and change in real time with any modifications that we make. So we can now click Execute Operation, and let's display the magnitude of our new summed curve. If we have a look around our crossover frequency, which is about 100 Hz in our case, and up until where the two arrays interact with each other, more or less 20 Hz below 100 Hz and 20 Hz above 100 Hz, we will notice that the sum of these two curves is not very precise. And this is due to the fact that the phases of the top and subgroups are not aligned. As we can see here, these phase curves display an offset between them and a slightly different slope. We can compensate for both with ArmoníaPlus. In this case, for example, we can make the phase slope of our top array group slightly steeper by adding some delay to it. When we judge that the slope of both curves is similar, we can invert the phase of our top curve to reduce the offset between them. and then make some finer adjustments to the delay of our top curve. We can reverse the phase back just to verify that our final result is exactly as we expect it to be, and there we go. And now that we have a final sum top and sub curve, we can also enable it to interact with other groups in our project, such as an advanced group, like the main group for example. In this group, we can also make further adjustments by applying a few EQ filters. And with these filters, we can easily adjust the low frequency content of our entire PA system. If we need to export this live curve to use it again in the future, we simply click More in the interactive tuning pane, and then select Export. And that's it. This is how we can use smart interaction to tune our system in ArmoníaPlus. If you have any questions about this or any other videos in the series, please feel free to contact us on support.audio@powersoft.com.